Hello friends, in the previous presentation we have discussed about the various types of hazards, various types of environmental stresses, environmental factors, and on the basis of these environmental factors we have defined the industrial hygiene. So how to control that environmental stresses and factors? There are different methods to control that may be at source, that may be at air path, or that may be at the end. So depending on the condition we can go for the elimination, we can go for the substitution method, we can go for the different engineering control technique, we can go for the personal protective equipments, etc. And then we have clearly mentioned that we are going to focus only on the chemical hazards, because when we are talking about the industrial hygiene, their controlling techniques, then we must focus only on the chemical hazards, because other techniques can be easily controlled, and there are various designs and technological developments are available to control all these physical hazards, then fire hazards, electrical hazards, etc. But for chemical hazard control, we must know what exactly and what are the types, properties of chemicals are available for using in daily routine in various types of industries. So there are thousands of chemicals which are used in industries like solvents, explosives, corrosive chemicals, toxic chemicals, oxidizing materials, toxic gases, inflammable materials, etc. And the examples of these solvents are benzene, toluene, xylene, then CCl4, etc. Explosive may be RDX, that may be a nitrogen derivatives, that may be a TNT like trinitrotoluene, etc. Then corrosive chemicals may be acidic, may be alkaline chemicals, may be acidic gases. Toxic chemicals may be cyanide derivatives like potassium cyanide, sodium cyanide, then hydrogen cyanide, etc. Oxidizing material may be a potassium permanganate like chemicals, and the toxic chemicals may be a chlorine, ammonia, sulfur dioxide, nitrogen dioxide, etc. Inflammables means which can easily catch the fire like paints, thinners, petro-based products, etc. So all these are the examples from the different types of industries. And the effect of these chemicals may be a acute, may be a chronic. So acute means of short duration, refers to a single exposure of limited durations. Like if your exposure time of a particular chemical like chlorine in seconds, then it is called as the effect is called as acute effect. The exposure time may be in minutes if the maximum permissible limit is more of that particular chemicals, and sometimes it is also in hours. So that depends on what exactly the adverse effect or health effect on your body due to that chemicals, due to that exposure. So generally when we are talking about the short duration and a normal effect on your body, on your health, then it is called as acute effect. So that effect may be like irritation to eye and skin, respiratory irritations. Some examples of these chemicals for these acute effects are ammonia. So due to ammonia, due to pungent smell, the irritation to eye and skin can be possible. Then solvents can be easily respirable by the human being, and some formaldehyde like metals can be again enter into your body. But the effects are a normal one or can be controllable, and the duration may be a short. That is why it is called as acute harmful effects. And the second one is chronic, that is of long duration, prolonged, repeated exposures over a period of days, that may be in months, that may be years. So exposures or doses relatively harmless unless repeated over long periods of time. The effects may be the diseases like cancer, heart disease, heart attack, or sensitizations. The examples of these chronic effects are smoking. So smoking is one of the activity that may be for a longer duration, and the effect is also for a prolonged time or for the longer time, and the effect may be in terms of cancer. So that is one of the example for the chronic effect. Then coal mine dust. So normally when the workers who are working in the coal mines, the coal dust is always present in that particular area, and these coal mines particles are respirable one, and that is why these coal particles are always respirable by the persons, and these respirable particles are deposited in the lungs on a regular time, on a monthly basis, on yearly basis, and after some years the medical examination can identify these coal mine particles in your lungs, so which can reduce the pumping capacity of the lungs, and which can adversely affect for a longer duration. That is why it is called as chronic effect. Other examples are wood dust and asbestosis. So if the asbestos particles which is suspended in air are available in working environment, then these asbestos particles are also respirable one, and these asbestos particles are going to deposit in your lung for a longer duration, and due to this asbestosis is one of the disease. It is also called as a notifiable disease, which is clearly mentioned in the Factory Act. So this is for the longer duration, and that is why it is called as chronic effect. Some other group of chemicals and their action is mentioned in this slide, that is respiratory and eye irritants. So some of the examples are sulfur dioxide, ammonia, chlorine, and formaldehyde. Then chemical effects on lungs, silica, and due to this silica, silicosis is the disease. Due to this asbestosis is the disease. Due to this cotton fiber, fibrosis is the disease. Then chlorine, various types of dust can be adversely affect on our lungs or can be deposited in your lungs, so that these lung capacity can be reduced. Then chemical effects on blood systems. Carbon monoxide is one of the chemicals which can directly reacted with your blood, and which can create carboxyhemoglobin instead of oxyhemoglobin. And due to this carboxyhemoglobin, temporary judgment of a person can be hampered. And other chemicals like nitro and amino compounds of benzene, lead, arsenic, benzene. All these chemicals are directly reacted with the blood systems or with the hemoglobin. So all these are toxic and poisonous chemicals. And some of these chemicals can be entered to your body or your blood system through the skin also. Then central nervous systems, depression chemicals like carbon disulfide, that is CS2, methyl alcohol, mercury, lead, and manganese. So all these chemicals are directly affect or directly attack on the central nervous systems. So the effect may be a temporary one, or the effect may be a chronic one. Then carcinogenic substances, like the substances which can cause the cancer, are called as carcinogenic chemicals. So for examples, aromatic amines, benzene or benzene derivatives, then bichlorodimethyl ether, chromium, radium, etc. All these are the different chemicals and their effect or effect on your particular body part. Then other chemicals like corrosive chemicals, acids, alkalis, chlorine, ammonia, sulfur dioxide, so which can cause the corrosion. Then liver affecting chemicals, that is organo chlorinated compounds, trichloroethylene, tetrachloroethylene, vinyl chloride, etc. So we are using all these chemicals in various types of products, manufacturing processes, and which can directly affect on our liver. Then mercury oxalates, then polycarboxylic compounds are affecting on your kidneys. Primary irritants, sensitizer causing dermatitis. Dermatitis means the skin diseases. Pigmentation on skin, then oil acne, burns, etc. are the minerals, oil, resins, and various other chemicals which can affect directly on your skin. Then CS2, lead, mercury, arsenic, cadmium, ethylene oxides can directly affect on your reproductive system. Then nitrogen, acetylene, butane, methane, or carbon monoxide, hydrogen cyanide, hydrogen sulfide, etc. can affect on your lung systems or your respiratory systems. So it is called as asphyxiant. So asphyxiant means the chemicals which gives us the feeling of suffocation. So when we are not having a sufficient amount of oxygen to breathe, then the chemicals are called as asphyxiant and the feeling is called as suffocation. So these are the different groups of chemicals and their action on our body. The main chemical or the main pollutant in this area when we are talking about the industrial hygiene is airborne contaminants. So the airborne contaminants may be gases and vapors. That is one of the airborne contaminants. Other contaminants we will discuss later on. So gases, we know about the gases characteristics, and the particle size of these gases is from 0.005 to 0.01 micron. The examples are chlorine, ammonia, sulfur dioxide, hydrogen sulfide, hydrogen cyanide, carbon monoxide, etc. So main pollutants are the oxides of the carbon, sulfur and nitrogen. It is also called as SOx when sulfur derivatives or sulfur oxides are there, and it is also called as NOx when nitrogen oxides are there. And for the carbon, mainly the chemicals are carbon monoxide and carbon dioxide. So all these chemicals or these pollutants are available wherever the combustion is there, because we are using fossil fuels like oils, coal, petrol, diesel or their derivatives, which are nothing but the hydrocarbons. And when the hydrocarbon as a fossil fuels are using, there are some sulfur contents are always available in that fossil fuels. And due to the combustion, these sulfur is going to convert into SOx. This nitrogen which is present in the air is going to convert into NOx, and the carbon from the hydrocarbon material is going to convert into CO or CO2 depending on the complete or incomplete combustion process, and hydrogen is going to convert into H2O. So all these are nothing but the gases which is airborne contaminants. Then vapors. The vapors are the gaseous form of a substance which are normally in the solid or liquid state, which can be changed to these states by either increasing the pressure or decreasing the temperature alone. So depending on this temperature and pressure criteria, these substances can be converted into vapors. So vapors diffuse, and the particle size of these vapors is ranging from 0.005 to 0.01 micron. The examples of these vapors are lead oxide, benzene, xylene, trichloroethylene and other solvents. So mainly when we are talking about the solvents, so all these solvents can be vaporized in the air depending on the temperature and pressure conditions. The gases and vapors are also classified as organic solvent vapors, pulmonary irritant gases, upper respiratory irritant gases, chemical asphyxiant gases, simple asphyxiant gases or other inorganic and organic gases. So examples are given here. So these gases and vapors are also classified in a such way. Why it is classified in such way? Because if you want to control all these gases and vapors, or if you observe any symptoms or sign in your body regarding the pulmonary diseases, which is nothing but the lung diseases, then we can go for the controlling of this chlorine, NO2, phosgene, etc. If there are some issues like suffocation, then we must observe this carbon monoxide or HCN, etc. So depending on the observations, depending on the monitoring, depending on the analysis, we have to control these gases and vapors in the industries. Then other airborne contaminant is particulate matters. That is normally called as PM. Capital PM is nothing but the particulate matters. So these PM are produced by blasting, crushing, drilling, grinding, mixing, etc. So from these operations, these PM can be produced and which can be suspended in the air. So this suspended particulate matter is one of the terminology that is also called as SPM. So if this suspended particulate matter is respirable one, then it is called as RSPM, respirable suspended particulate matter. So nowadays the State Pollution Control Board or Central Pollution Control Board is going to focus, going to monitor, going to assess or test on RSPM, because these RSPM are directly or adversely affect on our health. That is why they are going to focus on the RSPM limit instead of SPM or PM limits. So under this particulate matter, one of the example is dust. So solid particles generated by handling, crushing, grinding, rapid impact, detonation, decrepitation of organic and inorganic materials such as rocks, ore, metal, coal, wood, grain, etc. are the examples of this dust. So this dust do not tend to flocculate except under electrostatic forces, and that is why it is dangerous, because this dust, when it is suspended in the air, can be respirable and can be absorbed through the air and can be sent to the lungs through the respiratory systems. They do not diffuse in air but settle under the influence of gravity. So if you use the gravitational force, if you use the electrostatic forces, it means if you are going to use the cyclone separators, if you are going to use the electrostatic separators, if you are going to use the Venturi scrubbers or settling chambers, etc., then we can reduce the quantity of the dust in the air. The particle size of this dust is from 0.1 to 1000 microns, and flash from the chimneys varies from the 3 to 80 microns, which is more dangerous. So this is about the dust under this particulate matter. Then this chart is clearly showing what exactly the range of this particulate matter, that is size of the particles, natural as well as industrial. So if you observe this 0.001 micron up to 10,000 microns. So if you observe the particulate size or particle size of the solid aerosols, which is mainly ranging from the 0.1 to 10. So in this criteria, that is from 0.1 to 10, the atmospheric dust, the welding fumes and dust, tobacco smoke, coal dust and cement dust are involved. So this is the main range where most of the solid aerosols are covered, that is from 0.1 to 10. Then under the particulate matters, the fumes are also there. What exactly the fumes are? Solid particles generated by the condensation from the gaseous state, generally after the volatilization from the molten metals, etc. So the metal fumes, which is created from the molten metal in the foundry industry or in the industries where we are going to use the melting process for the metals. So fumes can be generated. So from the liquid stage to the solid stage in the air, if these solid particles are generated due to the condensation technique in the gaseous state, then it is called as fumes. So examples of these fumes may be lead fumes, zinc, then nitrous fumes. And the particle size varies from 0.001 to 100 microns. So these fumes flocculate and sometimes squirrels. So depending on these characteristics, we can go for the flocculation, we can go for the coalescence process for absorbing or for separating out these fumes. Then mist is another concept, that is suspended liquid droplets. So these suspended liquid droplets is called as mist, and that may be generated due to the condensation from the gaseous to the liquid state, or by breaking up liquid into the dispersed state, such as splashing, foaming, and atomizing. So when we are using the atomizer in the paint industry or in the painting department, in the automobile industry, etc. So due to this atomizing or due to this foaming or splashing technique, mist can be generated. The particle size of this mist is from 50 to 100 microns, and the examples are sulfuric acid mist. So this sulfuric acid manufacturing process may have the mist in that environment. Then smoke is another parameter or terminology, that is the small gas borne particles resulting from the incomplete combustion. So incomplete combustion is the process where oxygen is not as per the calculations, that is called as theoretical oxygen. So whatever the oxygen provided in that combustion process is less than the theoretical or the stoichiometric requirement of that oxygen, then the combustion is called as incomplete combustion. So in this incomplete combustion, this smoke can be generated. So carbon gases material, normally when we are talking about this particle size, it is from 0.1 to 1 micron, and if there is incomplete combustion, then obviously there is a carbon monoxide. So if these particles are present, then it is called as smoke. Then smog and fog. So the air contaminants may be present in the form of smog. Smog means smoke plus fog. So we already discussed about the smoke, that is due to the incomplete combustion process. The carbon particles are present like carbon monoxide, and if there is a fog, that is moisture, then this combination of the smoke plus fog is called as smog. Right? So this is the smog concept, and the particle size is from 1 to 50 micron. Then aerosol is another terminology under these airborne contaminants, and which is important from the industrial point of view. It is a colloidal system in which the dispersion medium is gas and the dispersed phase is solid or liquid. The term aerosol is applicable till the solids or liquids remain suspended in the gaseous medium. So these solids or liquid particles are suspended in a gaseous medium. The particle size ranging from 0.01 to 100 micron, and the examples are dust, smoke, and mist. So these dust, smoke, mist we have already discussed. These are the examples of these aerosols. It means the solids or liquid particles are suspended in the gaseous medium, which is called as aerosols. So aerosols affect weather, damage materials, and impair health. Atmospheric aerosols like hydrocarbons, lead, arsenic, sulfur acid, etc. may injure human health because of their toxic nature, and that is why we must control all these aerosols in the industries. Thank you. So these are about the airborne contaminants and their different terminologies and examples.